There's one other example I wanted to show you. This is just a special case, but it's one that sometimes confuses people, so I wanted to mention it explicitly. This problem that I'm showing on the screen here, 4.4.5, this is another problem that asks you to convert from magnitude direction form to component form. We have a vector A that has magnitude 4 and points in the x direction. So what are the components of this vector? What a lot of people do on this problem is they try to use the method that I explained, and step one is draw a right triangle. And it's like, wait a minute, what right triangle am I drawing here? This is a special case. If the vector is already parallel to the x-axis or the y-axis, then you can't draw a right triangle using the instructions that I gave you previously, because you would need to draw one side of the triangle, one leg of the triangle, parallel to the x-axis, but the hypotenuse is parallel to the x-axis, so that doesn't work. That's because this is just a very simple case that you can read off by eye. Since this vector points in only the x-axis, you'll notice that, like, if you think about this using the other approach that I explained of thinking about it like Cartesian coordinates, if you were to give the Cartesian coordinates of this point here, the Cartesian coordinates would be 4, 0, right? It has y coordinate 0 because it's on the axis. It's at y equals 0. So as a result, this guy is just going to have ax equals 4, ay equals 0. And there's no trig to do in that case. So a vector that points parallel to the x-axis has y component 0. A vector that's parallel to the y-axis has x component 0.